vectors here, one of which we know exactly, one contains an a. We're asked, first of all, to show that the magnitude of the vector OA is root 38. Actually, what we can do is just use 3D Pythagoras' theorem. It's only one mark. It's going to be 5 squared plus 3 squared plus 2 squared, all square rooted. Because it's a show that question, let's just make sure you show enough work and don't go straight to the answer. 25 plus 9 plus 4. I think we can do it from here though. Root 38. Great. I'm just going to show where that actually comes from. So if I draw a cuboid, any vector in three-dimensional space could be drawn going sort of along, up, and into or out of the page. I'm moving in 3 dimensions here. Basically, I'm trying to find the length of this diagonal, which is exactly what the length of a vector is. So let's say the base is x by y, and the height is z. Then what I could do is, if I draw in the rest of the cuboid going down and along like that, then I can draw a diagonal going along and then up. I've created a right angled triangle. This is why I call it 3D Pythagoras, because it's in 3 dimensions. So I could find the length of that base diagonal. It's actually going to be x squared plus y squared square rooted. Maybe I call that L. And then my magnitude, or maybe yeah, length. Okay, I'm just going to call it length of the line. That's then going to be L squared plus Z squared square rooted. Now L squared is actually x squared plus y squared, and hence we get this formula, x squared plus y squared plus z squared square rooted. That's a little derivation essentially of 3D Pythagoras, using 2D Pythagoras to help us. On to part B, find the smallest value of a for which this is true. Okay, well OB I can work out in a very similar way. It's gonna be 4, because I'm just squaring the 2, plus 16 plus a squared, square rooted, and that is going to be needs to be greater than root 38. Let me just clarify. This is OB and this is OA. Now, because both of these are positive quantities, we can actually square the inequality. You can't just square any old inequality, because negatives could really mess things up. But because they're both positive, we can. So I'm going to get 20 plus a squared is greater than 38, which means a squared is greater than 18. We are told that a is a positive integer. You're probably all right from here on to just square root. Yeah, no, we are okay actually. I was going to solve it like a normal quadratic inequality, which I will do at the end. But because it's positive, we can just say that a has to be greater than root 18. Don't always do this, by the way. If a could be negative as well, there's a whole set of other solutions that I'll talk about. Now, what's the nearest square number? Well, 4 squared is 16. That's less than well, root 16 is less than root 18, so 4 is too small. But the next one up is going to be 5. That's root 25. So that will be our answer. The smallest value of a, smallest integer that's above root 18, essentially, is root 25, which gives us a equals 5. Okay, just to say right at the end, so just be careful in general with something like a squared greater than 18. If a was, it could be negative as well. So the proper way to deal with this would be to minus 18 and turn it into well, it is a quadratic inequality, but I've now got 0 on the right. We could factorize it. It's actually going to be a difference of 2 squares, a minus root 18 and a plus root 18. The roots are root 18 and minus root 18. We'll sketch a little graph. Okay, I'm actually sketching y equals this function here. And so I want I'm interested in where it's bigger than 0. So it's going to be this side and this side. So a greater than root 18 or a less than minus root 18. Of course, this is, beyond what is necessary for this question. I'm just bringing in the general solution of a quadratic inequality while I'm at it. You could do it like that, and then again, you're back to where it, because we know a is a positive integer, you're back to using this one and getting 5. In this case, yeah, it's only a couple of marks. I'd say, yeah, this is definitely the way to go. So just look out when you have an inequality for whether things are positive, because then there are things you can do that you would normally do for an equation, but not for an inequality. But if it's all positive, then it's all okay. Actually, if it's all negative as well, then you can also, it's just when there's a mixture potentially of positives and negatives that it gets a bit more complicated. Anyway, well done with this question.